So for this example, we're going to determine the equation and graph of a line that is parallel to y is equal to half x plus 3, this linear equation over here, and passes through the point 1 and 1. Okay. So a couple of things here that we're going to do as a strategy. So the first thing we're going to do is we're going to start a new equation where the slope is equal to 1/2, since we know that it's parallel. So I wrote y is equal to 1/2 x plus b. Next, we're going to substitute the point given to us, which is at 1 and 1, right? The first value listed is the x and the second value listed is the y, into the new equation, and we're going to isolate for b, or the y-intercept. Then once we've solved for b, we're going to rewrite the new equation and graph it. So you could rewrite the equation in both these ways. Some people put the 0 just so that they know it's there, but it's not necessary in math. And so we're going to graph this equation here, starting from the y-intercept, of course. So in this second example, we're going to find the slope of the line that is perpendicular to a line given here in the standard form, x plus 2y minus 6 equals 0. So the first thing we're going to do is we're going to convert this equation, which is in the standard form, into slope-intercept form, or y equals mx plus b. And so what we're really going to do is we're going to isolate, and I'm circling the y here, we're going to isolate for y. Once we've got our line into slope-intercept form, we're going to get the perpendicular equation by taking the negative reciprocal of that slope. So this number over here. So instead of writing negative 1/2, we're going to go y is equal to positive 2 over 1 x plus 3. Or you could simply just write 2x plus 3. And I'll write that a little bit bigger here. It's the same thing. And remember, the negative reciprocal of a negative 1/2 is going to be just positive 2 over 1, right? Because the negative of a negative is a positive. So now we have the equation y is equal to 2x plus 3. And as the equation shows us here, the slope is 2 over 1, right? Where 2 is the rise and 1 is the run. For a final question here, we're going to find the equation of the line that is parallel. So we're looking for something that has the same slope to 7x minus 5y equals 20 and passes through point 1 and 2, where of course the 1 is your x value and the 2 is your y value. Okay, so the first thing we're going to do is we're going to convert the equation given and highlighted in green to slope-intercept form. And basically what we're doing is we're solving for y. Then we're going to plug in the point 1 and 2 into the new formula and solve for b, or the y-intercept. So again, because this is parallel, we're going to write an equation for the new formula that starts off with the slope 7 over 5x, and then we'll go plus b. And then what I'm going to do is I'm going to substitute the 2 where the y goes, and the 1 where the x goes. And then using algebra, we're going to solve for b. And this finally leaves us with the equation of 7 over 5x plus 3 over 5. And this value over here would be our, we could say, y-intercept. And so we have the equation of the line. Now, it doesn't say which form it wants us in. This suffices. But of course, if we wanted to transfer this to any of the forms, we could. And so what I'll do is I'll translate this. We're going to write or in standard form. And we're going to translate this into ax plus by plus c is equal to 0. And after some algebra, here is the equation in standard form. And I can rewrite this here in order so that it's minus 7x plus 5y minus 3 equals 0, where of course the negative 7 is your a value, your 5 is the b, and the c value is negative 3. But again, this is an extra step, and I'm just kind of show you, well, how we would convert this to standard form if it was asked. But if it's not asked, this over here is sufficient.